Good day, everyone. So we have a laptop to fix. This laptop is coming from another computer repair shop, but the technician who brings this laptop here is saying the laptop came in from a customer who bought this laptop on auction. We remember I fixed one which came in from auction, and this is another one which is coming from auction. You can see the sticker here. This is not our tag. So this is a HP ProBook. That's the laptop. Yes, came open like this. We have the motherboard, we have the screen, and that's all. So here is the story about this laptop. The laptop, he tried to fix it, but he could not figure it out what might be the problem. It's like the guy went to different computer repair shop, and at the end they send it here. So that the laptop, we have the motherboard, we have the switch, we have a heat sink, fan, DDR4 RAM. The motherboard looks nice, except one thing. Here is meant to have the HDD connector. Let me disconnect here because we want the motherboard. At the moment, let's focus on the motherboard only. Let's focus on the motherboard only. That's the motherboard. Yeah, now looks okay. That's the motherboard. We have a nice motherboard here. Some cores, all-in-one processor with PCH and GPU inside. Underneath this heatsink, we have the processor. We have those DRMOS for the vehicle section. We have the M2 connector here for SSD. Here is meant to have a HDD, and the connector is missing. We have some ripped off pads here. Maybe it's better to have a look on a microscope. You can see the connector. This connector is meant to be for the hard drive, and all the pads, they are ripped off. But I told the guy who bring this laptop, this motherboard here, that what we can do is to fix the motherboard, and when we fix the motherboard, the customer is no longer using HDD. You use a SSD drive, which is an advantage because it's a more bit faster. So we can try to see what this motherboard is doing. That is the first step. Plug in the power supply, and it's taking 1 milliamp. Okay. Let's press the power on switch here. Oh, it's dead. It's not even responding. So what we have to do now, we have to move forward. What is the next step? The next step is to see if we have any voltage on this motherboard. When I say any voltage, we are starting to check the main 19 volts power line, and if the 19 volts power line is present, we check for 3.3. But we can start with 3.3 on the switch connector. There's no big difference. Volts. First pin we have 2.18. Second pin we have 0.27. third pin we have 1.15, first pin we have 0. So first pin we have 2.18, second pin we have 0.5, this one we have 1.25 volts. So the way how the motherboard are working, we must have the condition for motherboard to start up. We must have the 19 volts, we must have the 3.3. When you press the power on switch, the 3.3 is being sent to ground once. That's the condition to start up the motherboard. When you press the switch, is sending the 3.3 once, and the E.C chip is reading all the power supplies. If everything is okay, it will communicate with the firmware from the BIOS chip and the CPU to start up the motherboard. So in our case, we don't have 3.3. If we don't have 3.3, let's go back to 19 volts. We have some power supplies here, coil, and some ceramic capacitors here. We have 4.21. And here, 4.21. Here, 0, 0. So here on this power supplies we have 4.21. Let me check for different power supply. Let's go on a different power supply here. Here, 4.17. 4.17. So at this moment we are agreeing that the 19 volts power line is missing on this motherboard. Okay? So if the 19 volts is missing, we can try to locate the input MOSFETs. Let's go on a microscope. Next to the charging port, why am I suspecting? Here we have the charging port here. This is the charging port. We have this big MOSFET. We have this MOSFET, which looks like it's bent or something. Let's check some voltage on the input section to see if the 19 volts power line is passing from the charging port. It's coming through this inductor and to the input of this bigger MOSFET. We have 18.9. Here we have 18.9. And here we have 4.18 volts. That means on the current sensor we have 4.17. So the first MOSFET is cutting down the power. I explained the reasons why this may happen. Either we have a faulty BQ chip, or the second MOSFET is fault, or we have short to ground on the end of the power supplies on the motherboard. So what we are to check right now, what we are to check, we are to locate the BQ chip. And what is this chip? I think that is our BQ chip. I think that is our BQ chip. If I'm seeing clearly, this is BQ chip 24780S. That is our BQ chip. So if this chip is the BQ chip, what you can check on the BQ chip, you can check for the V-in. We have a big track here and this capacitor, which I believe is connected here. Okay. Yeah, here we have 18.46, which is pin number 1, pin number 2, 3, 4, 5, 6. Pin number 6 is coming to this ceramic capacitor. We must have 2 point something volts. Oh, it's coming to this capacitor. 2.59. You can see this is the AC detect pin. Pin number 6 of the BQ chip. And we have a linear regulator output, which is supposed to be pin number. I'm not sure about this, but we must have 6 volts. So here we have 3. We have 7, 7. Let's check here on this capacitor. 6 volts. You can see 6 volts. So let's assume that we have a working BQ chip. Let's disconnect the charger, the power supply, and let's put our multimeter on diode mode. While we are putting on diode mode, we need to check to see if the input MOSFETs they are good. Drain to source. It's okay. Source to gate. It's okay. This small MOSFET. The small MOSFET, I told you. I was suspicious. What here? Looks like this MOSFET suffers too much heat here. You can see the surface, the top surface of the MOSFET. This smaller one. This is gone. Like zero resistance. So let's replace the MOSFET. Let's replace the MOSFET. This has to be a quick repair because we don't want to waste time here. Let's replace this MOSFET and see if that can solve the problem. I can't even see the number of the MOSFET written on top. That's not an issue. (4C50). 4C50 is this has to be an N-channel MOSFET. Let's check for short again. Drain to source. And the short is gone. So we need the replacement of this MOSFET. If we can get any. Let's see this one. 7412. Do you think this can work? But it has to work. This MOSFET has to work. This is MOSFET from another motherboard. Obvious doing same job. I need a little bit of flux just to have strong connection there. Always use flux. Flux is good to use. Good. Our MOSFET is now in place. So we need to cool down the motherboard and test. So this can be the only fault, or we can still have many faults on this motherboard. But trust me, if this laptop was sent to auction, maybe this is not the only problem. Or we might be lucky to be this problem alone. But in most cases, I'm not lucky. I'm facing motherboards with multiple faults. I think we can test. We can test. Yeah, the board is too warm, but it still is fine. Let's test to see if this motherboard is coming on. It's now taking 700 milliamps. It's now taking 7 milliamps, and we still have a dead motherboard. Let's check some voltage. If the 19 volts is now passing, I'm checking on some points where I checked before. On this ceramic capacitor here. Okay, volts. We now have 19 volts. So if here we have 19 volts on these power supplies, it means that our MOSFET is working. What about 3.3? We checked on the switch connector pin number 1. We now have 3.37. Pin number 2, 3 volts. Pin number 3, 2.36. And here, pin number 4, 0 volts. So what I will check? Let's check if the 3.3 is going to 0. Pressing the power on switch, maybe that's not the pin to start up the motherboard. Second pin is stuck. Third pin, which has 2.36, pressing is going to 0, releasing 2.35 volts. And my question is, because this pin is coming straight from the E.T.C chip, and we have 2.35 volts instead of 3.3 volts. Something's wrong here. Something's not right here. Definitely something's not working. We might have a dead controller, because here we have the Novaton E.T.C chip, or the processor. Why am I not checking coils? Why am I not checking coils? Because this looks confusing. But we can check coils, ohms. Let's check the resistance of every coil to ground. Every coil to ground. Here we have this coil. 27 kilo ohms. This one. What? Wait, what? We have 8 ohms. 8 ohms. Here. We have 8 ohms here. 15 ohms here, 20 ohms. So here, I think what we are checking here is not like a short, because if I put on diode mode, those coils must beep to ground. Those coils, they are beeping to ground because what we are checking here is the internal resistance of the processor. So don't get confused. This is not a short. Because this is the all-in-one processor with GPU, PCH, all under one chip. So this one is good. 137 ohms. This one 268. Here we have more coils here. This one good. 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 So what do you do in this case? What is the way forward? What is the way forward? The way forward is to check for voltages. We need to check for voltages here. We have to locate the 3.3 volts power supply. Volts. This one. What about this one? This one 5.26. 3.3. This is the 3.3 volts power supply. If this is the 3.3 volts power supply, let's see on a microscope. What we want to check, 3.3 LDO for the startup chip. But instead of checking on the power supply, I think we have to check straight on the EC chip. Some ceramic capacitors. We have 3.14 here. So there's no need to check the 3.3 LDO if we have voltage on the EC chip. It means the 3.3 always on is up and running. This board is off, but we have 3.3. So we have 6 milliamps, and when you press the power on switch, there's no change of currents. No, when I press it's changing from 6 to 7. Let's disconnect. Let's connect the power supply. 11 back to 7. 11 12 back to 7. 6. So we have to understand laptop motherboard repairs. If you see something like that, it means that 6 milliamps or 7 milliamps is not the right standby current. It's a little bit low. We must have like a 12, 11 milliamps standby current, but something is triggering that current back to 6 milliamps. So when everything is working, you have 3.3, you have 19 volts, still the motherboard is not working. Before we condemn the processor, before we condemn the EC chip, uh, remember one thing that we have to do. What about to reprogram the BIOS chip? What if the firmware from the BIOS is corrupt? Because remember, based on the history that we have, this motherboard, this laptop was bought on auction. Maybe it stayed for too long without being used, and the firmware from the BIOS chip, yeah, can be corrupt. We must have like some kind of stale firmware from the BIOS chip. So I have too much suspicious on the firmware of the BIOS chip. So right now, where's the BIOS chip? Here. We have the BIOS chip here. And this motherboard, yeah, here's one BIOS chip. Some motherboard we will find two BIOS chip. The one for backing up, and the main BIOS chip. So what I'm going to do here, let's check out the BIOS chip. Let's check out the BIOS chip. We have the programmer here. That's what we can do at the moment. That's our BIOS chip. We need to wait for this BIOS chip to cool down, and then we put it on programmer, and we can move on to reprogram the firmware from the BIOS chip. So all what you need to do is to put the, where's pin number 1? We have a dot here. So pin number 1 of my programmer is here. So we've put this programmer which I'm using is CH341A mini BIOS chip programmer. Let's put the programmer to the computer, and what we have to do now is to go on desktop, desktop. We need to open the program, detecting the chip. The chip has been detected, you can see. Now let's read data from the chip. Let's read data from the chip. Reading. We are now reading the bin file inside this BIOS chip. So reading complete. So here we can see what is inside this BIOS chip. Save. Let's save this file. Don't make a mistake of formatting the old bin before you do backup. Save this. HP ProBook J2 backup. Like this, and save on desktop. Now we've saved this on desktop. The next step is to erase whatever inside this. Let's erase. We are now erasing the chip and try to come up with the new firmware. I fixed this motherboard some time ago. I think we must be in a position to get the bin file of this motherboard. You must be in a position. Erase complete. We have successfully erased this chip. So now you close the program. You open the program again, detecting the chip. Now we need to, let's minimize this. Let's go on desktop. There's a guy who sent me some bin files from South Africa. So last time I think he sent me the bin file of this model. That's the reason why I love South Africa. People from South Africa, they are so lovely. HP ProBook. Yeah, this one, HP ProBook 650 G2 bin file. You can see this. So I'll go to the program. We open the file. We go straight to the bin files on the desktop. HP ProBook G2. We open here. Now we can rewrite this chip. Rewrite. We have to wait, because if we go on desktop, let's see. Here, let's see this backup file. You can see this is a 16 megabytes bin file. So we have to be patient here until we finish reprogramming this BIOS. Now we have successfully rewrite this BIOS chip. Let's close the program. Opening the program, we need to verify. Let's detect the chip. Now let's read data from the chip. We need to verify if this BIOS chip has been successfully written. Okay. Let me, or we can cancel here. Let's cancel this operation. Verify data from Windows. Buffer is empty. Okay. Okay, it's fine. Let's read data from the chip. We want to see if this BIOS chip is now having something inside. Now we have successfully read what the programmer has successfully read whatever inside this chip. Yeah, we have the bin file. I think we are good to put back the BIOS chip for testing. I think we are good to go. So let's see. Let's see. Let's see. That's the BIOS chip. What A? No, the pins for the BIOS chip. This programmer is bending pins straight. But that's not an issue. Okay, I think we need to do this on a microscope. Just to have confidence of what we are doing. We need to go on a microscope and use a soldering iron instead. Let's go on a microscope and have a look on the BIOS chip. That's our BIOS chip. That's our BIOS chip here. Yeah, I can see two pins, they are not soldered here. I'll show you. I'll show you the pins. We have this pin here. We need to press this down. We need to press this down. And let's use soldering wire. Let's put some solder there. On the other side, good. So I think we can test now. We can test. If this is not going to work, we have to stop. We have to stop, otherwise we can't fix anything. Or what we can do, maybe we can pay attention on the CPU section to see what's going on. We'll play with the power supply at a very low voltage. What we can do is to short pins on the RTC connector here for the BIOS battery, just to reset the motherboard. After that, I need to see, are we winning or not? Plug in the power supply. It's taking 14 milliamps, and we have lights. Huh? The motherboard just come by its own. Huh? We have light even here. Huh? We fixed it. We fixed the motherboard. Huh? But you know what? Let's not be happy. Let's not be happy before we see display. I don't trust this kind of motherboards. So let's take the frame. Let's take the frame and see. Let's not be happy before we see display. I'll connect the screen ribbon cable. Because this, but at least we fixed the power issue. That's more important, to fix the power, because on the display side, maybe if it's not going to display, we'll be changing some RAMs If we change the RAM, what else we can do? Because already we have reprogrammed this motherboard. If we change the RAM, we check the GPU power supply and the RAM power supply, and it's not working. We consider it no fix. Plug in. Yeah, it's coming. The board is coming on. It's taking 400 milliamps. I can't see the picture, but we reset this motherboard, so we have to be patient. Maybe 396. Fan is spinning. We have picture. Huh? It's working. You can see HP log. It's working. You see post error. We don't have the BIOS battery. We don't have the main battery. We don't have the SSD. But it's displaying. Huh? So this laptop came in like this. We don't have battery. We don't have anything. But I'm sure we are not going to face problem with the charging. It's working. We have a working motherboard. Is our switch turning on this motherboard? On? Off? Yeah, it's off. It's taking 21 milliamps. Press on. It's coming on. So the job is done. The job is done. It's taking long because it's trying to detect the SSD, and the SSD is not even inserted. So the E.T.C chip will be trying to detect, and it's working fine. HP log. So I think we are done with this repair. I think we are done with this repair. So let me disconnect the power supply. And yeah, like, subscribe, don't forget to turn on the notification bell for future updates. I can see on my OBS is close to 1 hour trying to fix this motherboard. That is the worst case, when everything is working but it's not working. When everything is working but it's not working, you know what I mean. I mean, when you have 19 volts, you have 3.3, the motherboard is not starting. Don't be quick to replace the E.T.C chip. Yeah, the E.T.C chip can be faulty, but the power supply was communicating with me. You plug in the power supply, it's taking 60 milliamps, and there's voltage drop, there's current drop, like a standby current from 16 to 7 milliamps. And I was too much suspicious about the BIOS. So yeah, that is a good lesson. We move from the power issue to the software issue. So it's very good because this mini programmer just saved us on this motherboard. So yeah, see you on the next repair. Bye.